Question number 73. How many time constants will elapse before the power delivered by the battery drops to half of its maximum value in an RC circuit? This is an RC circuit. We have a resistance R and a capacitor C. The value of this voltage on this battery remains constant at V0. When, let us say, there is a switch, it is closed at t is equal to 0, and at that point of time there is no charge on this capacitor. A current starts flowing. Because the voltage on this capacitor can be assumed 0, there is a voltage difference of V0 minus 0 or V0 across this R, and therefore the current, initial current I is equal to V0 by R. After some time, the capacitor gets charged a little bit here. There is some charge at here. Because of this, this capacitor gets some voltage. The voltage across this resistor decreases, given by V0 minus V on the capacitor. So the current reduces. So initially the current is high. As the time passes by, the current decreases and its graph comes out something like this. This is time t and this is I, which is a function of t, and it decreases. And the maximum value you can think of is V0 divided by R. Now the power delivered by this battery to this whole circuit is given by I into V. V is the battery voltage, which is constant. It does not vary with the time. Battery voltage does not vary. What varies is this I. And as I varies, P varies. And we know that the I is decreasing continuously. So if you look at the power graph, if I can plot the same thing, power here, it will start from something from here, and it will go like this, where this value P is this value I multiplied by V0. And I is given by, for this circuit, I is given by I0. It's a function of t, which means I is varying with time, given by I0 e to the power minus t by RC. At time t is equal to 0, this becomes e to the power 0 or 1, so I is equal to I0. At t is equal to infinity, this becomes 1 upon e to the power infinity, which is 0, so I becomes 0. So therefore, the power delivered will be given by P is equal to I0 into e to the power minus t by RC, this whole term, multiplied by V0. V0 is constant, I0 is constant, and these constants are given by, we do not need to find those constants, but for your sake of information, I0 is the max initial current, V0 by R. Notice that initially the power is maximum, power delivery is maximum initially. At some point of time, this power delivery becomes half of this initial value, and we need to find out this time t. So power is equal to here V0 square by R, because we can substitute I0 here in this equation as V by R, V0 by R. So power becomes V0 by square by R e to the power minus t by RC. The maximum power, the power is maximum right at the beginning when t is equal to 0. At that point of time, e to the power 0 is 1. So the maximum power delivery is right at the beginning, which is V0 square by R. And half of that maximum power is half of V0 by square by R. And then that becomes equal to this thing, this equation. We need to find out at what time does this happen. So V0 square by V0 square cancels. E to the power minus t by RC is equal to half. To solve this equation for t, we take natural logarithm. So log e to the base e is 1. This becomes minus t to the power RC. Log e to the base e, which is 1, is equal to log of 0.5, which is minus 0.69. So this t becomes this factor multiplied by RC, where RC is called the time constant. So after this much of time, the power delivery will become half of its initial value.